On Tuesday, August 5, 2026, over 6 inches of rain fell on Norfolk, Virginia in roughly 2 to 3 hours, and streets across the city turned into rivers. The National Weather Service Wakefield office confirmed 6.11 inches fell in the Ghent neighborhood alone, with Norfolk International Airport recording 6.33 inches during the same window. City officials called it a 1-in-100-year event, meaning rainfall this intense has roughly a 1% chance of happening in any given year. By the end of this video, you will understand exactly why Norfolk flooded this badly, which neighborhoods took the worst damage, and why this keeps happening in coastal cities like it. This was not a hurricane, not a storm surge, and not a river overflowing. It was rain falling faster than the ground and the drains could handle it. Let's start with why this particular city turned into a disaster zone from rainfall alone, when plenty of cities get heavy rain and stay dry. Most people assume flooding this severe needs a hurricane, but Norfolk's geography made this possible from ordinary summer thunderstorms. Norfolk sits at one of the lowest elevations of any sizable city on the entire U.S. East Coast, with much of it built on drained wetlands and filled tidal flats. Neighborhoods including Downtown Norfolk, Ghent, and Larchmont are literally constructed on land that used to be underwater, which means it wants to return to that state during heavy rain. The city's storm drainage system was engineered for the rainfall patterns of past decades, and it is now widely recognized as too small for today's more intense storms. Several factors stacked together that afternoon: an urban heat island effect that intensified the storm over the city itself, soil already saturated from weeks of earlier rain, and high tide reducing drainage outflow. Add the city's flat topography, which gives standing water nowhere fast to go, and you get water rising in minutes instead of hours. Now here's where the flooding stopped being a statistic and became a story of trapped people and submerged cars. The Ghent neighborhood, home to the Chrysler Museum of Art, the Harrison Opera House, and Old Dominion University, took the worst of the damage. Colley Avenue, 21st Street, and Llewellyn Avenue flooded so badly that the railway underpass at Colley and 21st, already a known chronic flood spot, submerged vehicles completely. Monticello Avenue, one of Norfolk's main north-south corridors, had multiple stretches buried under several feet of standing water. Eyewitness video captured drivers stranded when their vehicles stalled or got swept sideways by the current, unable to move forward or back. In multiple documented cases, bystanders talked stranded drivers into climbing onto their vehicle roofs to wait for rescue, rather than trying to walk through the current. At least one driver was recorded swimming to higher ground after abandoning a car that had become completely stuck in rising water. Norfolk Fire Rescue and Norfolk Police responded to a wave of calls about stranded motorists as the city activated its standard flood response protocols. Here's how far this stretched beyond just one neighborhood, because Norfolk was not the only city underwater that day. The flooding spread across the entire Hampton Roads region, hitting Virginia Beach, Chesapeake, and Portsmouth with the same intense rainfall. In Virginia Beach, the Sandbridge area and several inland neighborhoods flooded badly enough to strand motorists and force road closures. In Chesapeake, the Greenbrier neighborhood and the Deep Creek area saw flooding along major thoroughfares that residents rely on daily. In Portsmouth, flooding hit neighborhoods along the Elizabeth River, including parts of Old Town and Craddock, two of the city's older residential districts. The ripple effect on traffic was massive. Interstate 64, Interstate 264, U.S., Route 58, and several state routes all experienced serious delays or temporary shutdowns. Now let's look at how the city actually responded once the water started rising, because the coordination mattered as much as the rainfall. The Norfolk Emergency Operations Center activated its full emergency operations plan, coordinating Norfolk Fire Rescue, Norfolk Police, Public Works, and the Virginia Department of Transportation together. The city's wastewater utility watched its pump stations closely through the event, with several reportedly exceeding capacity briefly during the peak rainfall. Public Works crews worked through the evening clearing debris from drainage grates and inlets, trying to open up whatever capacity the system still had. Police shut down flooded roads across the city and pushed out public warnings telling drivers not to attempt crossing standing water. The good news buried inside this disaster is that there were no confirmed fatalities from the Norfolk flooding, though several minor injuries were reported. Most of those injuries came from people attempting to drive through flooded roads anyway. ignoring the exact warning that public safety officials had already issued. Damage assessment is still ongoing, but early estimates point to extensive vehicle damage, water damage to dozens of homes and businesses, mainly in Ghent and Larchmont, and infrastructure repairs across stormwater systems, roads, and traffic signals. Here's the bigger pattern this single storm fits into, and it is not going away anytime soon. This kind of extreme rainfall event has become more common across the southeastern United States, a trend climate scientists have documented for roughly 2 decades now. Warm air holds more water vapor than cool air, and global temperatures have risen by about 1.2 to 1.3 degrees Celsius since the pre-industrial era. That warming increases the atmosphere's water-holding capacity by roughly 7% for every additional degree Celsius, which translates directly into heavier bursts of rain from storms. Similar catastrophic flash flooding hit the northeastern United States in 2024, part of the same broader pattern researchers keep tracking across the country. Norfolk's other well-known problem, rising sea levels, compounds coastal flooding, but it does not fully explain this event. This was inland rainfall overwhelming the drains, not the ocean pushing in. Norfolk sits in the Hampton Roads region, which has the highest rate of relative sea level rise anywhere on the U.S. East Coast due to regional land subsidence. That combination, sinking land plus rising seas plus more intense rainfall, is exactly why city planners are now pushing harder for updated drainage and flood defenses. Local officials are already discussing faster investment in modernized stormwater systems, living shorelines, tidal wetland restoration, and updated flood maps for at-risk neighborhoods. So the August 2026 Norfolk flood was 2 things at once: an emergency that trapped drivers and flooded homes in a matter of hours, and one more data point in a pattern that keeps repeating. That pattern is exactly what the next video digs into, breaking down which American cities face the highest flood risk over the next decade and why.